The world is as we see. We see things in its vast beauties, its vast wonders. Everything just makes sense. The birds sing, the trees grow, the stars shine. However, when we look really close at these simple things, when we break down that beauty, mathematical beauties, mathematical truths reveal themselves. Probably the most fundamental and important concepts to mathematics and to the development of basically all the fields of science, such as physics, is pi, even though it's so simple and elegant. So come on guys, let's go eat some pie. Phew. Alright, so let's get started. First things first, my name is Hyun, or aka Johnny, and I'm here with my magical hands and my wonderful clays to give you all a fundamental understanding of the beautiful world of pi. So we've all been taught that pi is 3.14. Even during my grade 7 year, we were just told that pi is 3.14 and that it's an irrational number. However, I always wondered where pi came from. Why is it so special? What makes it so special? It is this mathematical constant that just goes from 3.1459265 yada 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 yada. This constant is a ratio of the circle's circumference to its diameter. But then, we know that the formula of circumference is 2 pi r. There's a pi there. How then did people in the past figure out circumference without pi? Initially, what ancient mathematicians did was they used regular polygons, such as pentagons, to estimate the circumference of a given circle by having inscribed and circumscribed polygons. For example, you would start with a square, then pentagon, and then you would keep on increasing the number of edges to get as really close to the circumference of a circle with a given apothem, or radius. Let's try using a square to estimate the circumference. If you have a length of 1 for a square that is circumscribing a circle and an inscribed square that has a diagonal of 1, the perimeter of the circumscribed square is 4. For the inscribed square, since we know that the diagonal is 1 and we know that all the sides have an equal length, using the Pythagorean theorem, each side is square root 1 over 2. Therefore, the perimeter of circumscribed square has a perimeter of 4, while the inscribed has 4 times square root 1 over 2, which is around 2.82. By increasing the number of sides, the perimeters of the circumscribed and inscribed polygons get closer to pi. And mathematicians have been using this method to keep on computing digits of pi. However, ancient mathematicians had difficulties computing so many values by hand. Then, the infinite series was created, such as pi is equal to 4 over 1 minus 4 over 3 plus 4 over 5 minus 4 over 7 yada yada yada, which can compute a value close to pi as these numbers keep on adding up. There are many different infinite series. However, each series has different rates of convergence, as in the rate at which it gets closer to the true value of pi. Later on, with computers, hundreds of millions of digits were able to be computed. Now you get the origin of pi. However, now the question still lingers. Why is pi so important to basically all the fields? The short answer is everything has, or nearly everything has a curve or circle. The big answer is a lot cooler. Take for example, a fun physics experiment, the spring. Say you have an object that's attached to the spring and you push it. The object will move inwards then outwards, with its initial position being 0. If you graph this observation and experiment, guess what? You get a curve. Therefore, you can model this curve using pi. The reason for this is due to the inherent property of a circle. Since we know that pi is part of the circle, every time we make a rotation relative to pi or radian, it produces a curve depending on what side you're looking at, such as sine and cosine. In a circle, there are sine and cosine, in which sine representing the y value and cosine representing the x value. Therefore, using these functions, we can model the world around us that requires circular concepts using pi. And this is why pi is so important. It's not just some infinite value that you learn in school. It's a value that is needed in everything, from putting a satellite around Earth to creating statistical models. Many things have curves, either directly or indirectly, visually or graphically. But to make sense of the world and change the world around us, we need pi. It's also a good number to test computers, and sure is good to eat, especially apple pie.